They are 9 trillion kilometers from Earth. These are 2 giant space objects deep within an alien galaxy. The faintly colored crust is the nebula NGC 2014. In blue tones, NGC 2020, smaller, but its images were eagerly anticipated on Earth. The Institute of Space Telescopes spent several months locating an object for this survey. In astronomical catalogues, compiled since the 18th century, they found a vague entry under the number 2020, which seemed fitting for the 30th anniversary image of the Hubble telescope. A spectacular neighboring nebula would be imaged at the same time. In 6 weeks' time, the image will be ready to be displayed. What we're seeing now isn't what the telescope actually transmitted to Earth. Its images looked like this. Here are more examples of the discrepancies. This is the Monkey Head Nebula in the Eagle constellation. An image that came from space has been transformed. Another nebula, in its original color, bears a similar name. It's the Horse Head in the Orion constellation. And this is a colorized version before it's released for public viewing. We can't see the universe with our own eyes, and telescope images are one of the few things we can use to visualize galaxies whirling in spirals. About the stars. They're exploding, they are turning into red and white dwarfs. About planets, perhaps similar to our Earth, or maybe connected in a system. And each planet has its own, almost paradisiacal world. These are all the scientific discoveries that have come to light. And there's more of this astonishing news about the universe. If what we're told and shown is altered or embellished, what is it really like? How is the universe tens of light years and trillions of kilometers away from us? We also base our knowledge of the closer Mars on the images spacecraft send to Earth from the surface of the neighboring planet. And these images are also brightly colored. Do these landscapes look too good to be true? There's science behind it all, of course. And through the dark universe, it moves by feel. Stars, even in the most powerful telescope, are just dots. A little brighter, a little dimmer. The galaxy is an array of dots, and the planets are invisible. Their position is calculated over years, watching for anomalies, modeling, and making discoveries. Sometimes everything measured, discovered, and researched falls apart because it couldn't be confirmed. Some space objects of colossal size have been hypothetical for decades, even within our own solar system. Will we ever be able to confirm their existence or, conversely, to disprove them? Those who are the first on Earth to see images from the farthest reaches of the universe understand the intricacies of scientific research. And they comprehend better than anyone else. Space is an infinite land of wonders, which we are unlikely to ever fully comprehend. Behind Joseph de Pasquale on the wall are his works, almost dreamlike images. But these are photographs of objects that do exist in the universe. Representatives from the Hubble Space Telescope Institute will reveal for the first time how images taken from space are processed. Now, the data from Hubble come to us as FITS files, Flexible Image Transfer System files. They are stored on the telescope's storage system. When I start working with the images, I retrieve them from storage and they come to me in black and white. My job is to take images from the Hubble telescope and transform them into stunning visual paintings. There isn't such a variety of colors in space. Looking through a telescope or the viewport of a spacecraft, a person will see, at best, indistinct imprints in gray tones. Even if you fly close to these objects, there will be no blue, red, yellow, or green. but they are depicted as if they were photographed with all the color diversity. Details and transitions of one color to another are clearly visible. The narrator describes the two nebulae in such detail as if he saw them in reality. De Pasquale doesn't deny that he receives images that are dull and impersonal. It's hard to see anything. Furthermore, there are often defects due to cosmic rays or starlight. All this has to be cleaned up. But the main problem is the blurred image. The Hubble telescope is constantly moving. To focus its sensors on the right object, it needs to locate it. That's where bright stars come in handy. They serve as the telescope's guide. And secondly, try to focus on the object for a while. It's challenging. When Hubble captured two nebulae for the anniversary image, it lost the guide stars, began to drift and shift, resulting in unclear images. To obtain the best quality images, the telescope was redirected towards the nebulae 3 times over 2 months. All this time on Earth was spent in anticipation. When the images arrived, they began assembling them. Initially, it appears like a mosaic of colorless tiles. Robert Hurd is a NASA engineer at the Center for Image Analysis and Processing at the California Institute of Technology. He, too, is transforming the universe before it's viewed by non-specialists. Data from the Spitzer telescope is sent to him. It captures pictures of the cosmos in the infrared spectrum. Hurd takes these remarkable images and turns them into pictures so expressive that they can be observed without straining. Using filters, astronomers distinguish between short, medium, and long wavelengths of light. Depending on what's in the picture, a color scale is determined. This is the Whirlpool Galaxy, not bright, but certainly captivating. The final color is composed of data from 3 spectra: visible, infrared, and X-rays. Blue, red, and green are the primary colors. However, most images contain many other shades. Their selection is not always based on scientific criteria. The stunning illustrations aren't merely for admiration. During its 30 years in Earth's orbit, Hubble has captured billions of images, making it an immense digital repository. The Space Telescope Institute was specifically established to process data from Hubble. None of the existing labs, let alone individual astronomers, could handle the deluge of data about the universe that began pouring onto Earth. This massive volume of unique material must be analyzed, understood, and organized. To make it more understandable, they decided to apply color. The material processed comes not only from Hubble, but all telescopes, spacecraft, and probes. Occasionally, for scientific purposes, images are deliberately incorrectly corrected. This is not the case with distant galaxies, but with what's closer to us, the neighboring planet Mars. It's red, that's true, but we've been misled about many other things, ostensibly for research purposes. This spacecraft is dispatched from Earth to send back the most precise pictures of another planet. The Curiosity Mars Science Laboratory is safely encased in an aerodynamic capsule. It is departing from Earth. Some 500 million kilometers of interplanetary space lie ahead. In 8.5 months, it will have less than that to traverse. The star of this video will be Mars itself, glowing in rich, sunny shades of red. The closer it gets, the brighter it becomes. On August 6, 2012, when Curiosity actually lands on Mars, it will immediately transmit the first images back to Earth. They will appear as follows. This is Mount Sharp inside Gale Crater, where the rover landed. Here are the elevated regions of the same mountain. And this is at the base of Mount Sharp. It's Curiosity's primary research site, so almost all of the images are from this same area of Mars. Each one does not reflect the actual surface of the planet. This is a genuine image, and the next one is a modified version. These are the images viewed by the specialists who receive the raw material. It can be found on the website of NASA's Mars Exploration Program. Here are over 7,000 raw images transmitted by Curiosity to Earth. But even scientists rarely use them. They prefer the enhanced Mars. It's not just the color of the surface that changes. The sky and even the sun do, too. The Mars rovers are never situated flat on a horizontal surface, and their cameras are directed at the ground to study the terrain. The sky is seldom in the frame. To ensure it is still in the image, a panorama of hundreds of images is assembled. You can discern their boundaries by the beveled edges. And the sky is blue, which it never is. Professor Kurt Ehlers from Nevada examined the optical properties of Earth's atmosphere and compared them to those of the Martian atmosphere. He noticed that images from Mars showed clear discrepancies compared to what was expected. His main interest, however, lay in the sun, whose true blue color is visible in only a handful of photographs. Ashwin Vasavada, the deputy science manager of NASA's Mars Science Laboratory program, admits that almost all images of the Martian sky and sunset are color-corrected. These image sections are processed simultaneously with Mars' surface, the primary target for color corrections. As a result, irrespective of their actual appearance, stones and sand are depicted as they would look in Earth daylight. This artistic intervention aids geologists in identifying rocks and understanding the natural conditions that shaped them. Geologists compare the strata in Earth rocks to those in Martian rocks to deduce whether water ever existed in Martian craters. Exploration of this alien landscape relies on such comparisons. The same approach was applied when a ground-based telescope recently discovered 7 planets near a single star, named the Robert Trape Stone System. Each planet soon had a detailed profile of its parameters. Some of the discovered planets closely resemble Earth. 3 of the 7 planets were classified as Earth-like, implying that they orbit their star at a distance similar to that between the Earth and the Sun. Consequently, they have similar climates: cold regions where it's cold, hot where it's hot, and temperate zones. Planet D, in particular, shows promise. F and C, on the other hand, are considered analogues to Earth's neighbors, Mars and Venus. Observations of Planet G indicate that its atmosphere is likely composed of hydrogen and helium, with methane in the lower layers, much like Neptune. Therefore, like Neptune, the atmosphere of Planet G is expected to exhibit strong winds. Other planets are analyzed similarly, with comparisons made to Jupiter's moons, Io and Europa, one renowned for its volcanoes, the other for its ice. Modeling based on existing examples is a principal method of space exploration. Nearly all astronomical objects are studied this way. It's the only way to hypothesize what unseen cosmic entities might look like, whether they are in another galaxy, near a distant star, or on a planet whose distance we can't measure.